Alright, these guys are kind enough to let me watch this process.
There's a lot of preparation. Notice the gap. They've cut away a section of the rail. Before they do that, they have to unbolt the old section. Once the workers have cleaned the exposed rail ends, removing rust, grease, and anything that could contaminate the weld, they position the rails precisely, within millimeters. They align and then clamp them in firmly in place. A special two-piece mold is set around the gap. This mold will contain the molten steel once the reaction starts, shaping the weld so that it bonds properly to the profile of the rail. They are using a material called Thermite mold sealing compound. It closes the gaps, prevents molten steel from escaping, stops oxygen drafts, and maintains mold pressure. Next comes the preheating phase. A powerful oxy-fuel torch is used to bring both rail ends up to temperature. This step drives out moisture and reduces the thermal shock when the molten steel is poured. Preheating also helps the weld fuse more evenly, preventing weak spots. Every weld is documented. They write it directly onto the rail for identification, record keeping, and quality control. It can contain things such as the batch number and the weld number. Once everything is aligned, clamped, and heated, the crew is ready for the main event, the thermite reaction. A crucible containing a mixture of aluminum powder and iron oxide is placed on top of the mold. When ignited, it produces an incredibly intense exothermic reaction, reaching temperatures over 4,000 degrees Fahrenheit. The aluminum steals the oxygen from the iron oxide, leaving behind pure molten steel. The lighter aluminum oxide slag raises to the top. When the crucible's plug is released, the molten steel flows straight down into the mold and fills the gap between the rails. This is the moment when the two rails become one solid piece of steel. After the reaction finishes, the steel begins to cool and solidify. The crew waits until the temperature drops enough to handle the mold safely. Once it's ready, the mold is cracked open and removed. The leftover slag is knocked away and the excess steel, called the riser, is cut off or sheared away. To finish the job, the weld is ground smooth, so it matches the height and contour of the existing rail. This step is crucial for ensuring a smooth ride and preventing impact damage as trains pass over. And that's how a thermite weld is made. One solid joint that can handle millions of pounds of train traffic for years to come.